Hey everybody, this is Mr. Bells again. This is section 8-2 of your sequence and series section. These are what the problems look like. Going to try and go through some of these things, hoping that they make sense for you. Okay, so arithmetic sequences are simply sequences like this, 3, 5, 7, 9, that are going to go up by the same amount through addition every time. So an addition of 2, an addition of 2, an addition of 2. So arithmetic means there's a constant addition going on, or that means that the difference between each term is the same. Okay, where that's a sequence. A series simply means to sum up that sequence. So basically like 3 plus 5 plus 7 plus 9. So if we're going to talk about a sequence, it's just a series of numbers separated by commas. If we're talking about a series, then we're adding them up. Those are the main key words for it. Okay, so number 1 says complete the sentence. A constant difference between consecutive terms of an arithmetic sequence is called and that's pretty basic. It's called a common difference. And you can see on the one that I just wrote up there, the common difference is positive 2. Now, just to be clear on this, if this was actually going backwards, like this one, say maybe 12 and then 8 and then 4, this is arithmetic because it's going by a difference of 4 each time. But the difference in this case would be minus 4 because it's getting smaller. Plus 2, minus 4. Good deal? So how do we check? We simply look between each consecutive term and go, what's happening to it? Well, if I check this one and I look at this and I go, do the difference between them, what's the difference between 1 and negative 1? And I want to start with the second term and subtract the first term. So negative 1 minus 1 is negative 2. Negative 3 minus negative 1 is negative 2. Negative 5 minus negative 3 is negative 2. And negative 7 minus negative 5 is negative 2. So you can see the sequence is definitely arithmetic because, so it's probably a yes. I don't honestly know what the boxes are because I don't have that printout. Because there is a constant difference between two terms. Okay, so you should be able to, based on that, again, just do subtraction for each one and see if they are changing by the same amount every single time. And if they are, through addition, then we know it is that. Okay, so I'm going to jump a little bit into this one because those next ones are all just asking you, tell me whether it is, tell me whether it isn't, is it, isn't, is it, isn't. And some of them look a little bit more difficult, but like on this one right here, I'm going to check this one. So I have a half, and then I have 3/4, and then I have 1, and then I have 5/4, and then I have 3 halves. I'm like, dang, that's kind of confusing because those are all different denominators as you're going through here. So one of the things that I would look at for you is to, one, you could change it to a decimal. So this is 0.5, and this is 0.75, and this is 1, and 5/4 is 1.25, and 3 halves is 1.5. And you can see on each one of those it's going up by 0.25, and changing to a decimal might be easier than dealing with fractions. But again, all you'd have to do is take one term, subtract the term before it, and do that for each of the terms. Now, if it works for 3 of them, but it doesn't work for the 4th one, then it's not considered a sequence anymore. So it has to work for all the terms, okay? And here is one of the general formulas for it. It says a sub n, and n is just a subscript. It's kind of like a counter. It tells you which numbered term that you're at, equals a sub 1, and that's the first term, plus n minus 1, where n is a variable that refers to the number of terms that you're talking about in this sequence, times d, and that's your common difference. So like on this one again, common difference was 0.25. So that's the d, so how much it differs by. So one more time. A sub n is whatever nth term you want, or n is just a little subscript. So like if you want to know what a sub 8 was, that's asking you what's the value of the 8th term. A sub 1 is the value of the first term. N is the number of terms that you're going to deal with, where that n and that n are the same number. Okay, but this n represents a counter, so the subscript for that. And d is a constant difference. So this one says the first term is -3 and the term is 6 less than the previous term. So if I go ahead and plug this in here, and I'm going to do this 2 different ways. So it says write a rule. So a rule is one of these suckers right here. So a sub n is equal to a sub 1. That's what that says, right? And the first term is -3, so -3 plus n minus 1. And it says is 6 less than the previous term. So times -6. So that's the general rule. Now if I simplify this, this -6 has to multiply in here, and then I get -3 plus distribute there, so -6 and distribute there, and I get plus 6. So a sub n equals -6, and positive 6 and -3 is positive 3. Okay? So that's kind of how it goes, and that's one way you could do it. That's the way the book teaches it. I'm going to show you on this one how I'm going to do it, because I don't necessarily like the way the book does it. But it'll always work, and that formula is nice for some other things. But it says, this one says the first term is 7, and each term is 5 more than the previous term. Okay, so 7, and then I'm just going to put 5 more than the previous term. So 7, and then 12, and then 17, and then 22. I'm just going to kind of show you that pattern. And I know that the constant difference is a positive 5. So I'm simply going to write it this way this time. I'm going to do, here we go, a sub n equals 5n. And what I'm going to say is this thing, whatever I add or subtract to it, I'm going to call it the fixer, the thing that fixes it to get it right. It's simply this one. So if this is the first term, it's the term right before it is the thing that fixes it. So let's go backwards. 22, 17, 12, 7, and I go down 5 more. I know that that's 2. So I know my fixer is 5n plus 2. Isn't that easy? Well, I think that's pretty easy. So again, that's what we call the fixer. And to find out what I have to add to the common difference factor right in here, the 5n, it's just whatever term will make that work out for you. So you can go ahead and write that one in there. Okay? So I believe that we've just covered 2 ways. You can do it like this and solve the problem like this, or you can do it like this and solve the problem like that. As long as you know what you have to do to be able to get the a sub 0 term, or the term right before a sub 1. Okay, so this one says write a rule for the nth term of the sequence, then find a sub 20. So just to be clear on this, so what they're asking you to do is they're going to say, hey, write something, a sub n equals something here, and then find out what the 20th term would be. Now you could go old school and you could go, hey, this is going up 8, this is going up 8, this is going up 8, and just keep going up until you get to the 20th term way out here. But our goal is, if we can get a formula, ching, 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 right here, we can just use the formula to find any of them. So that if I said, well, what is a sub 5,216 equal to, you could just use that formula. Because trying to add 5,216 times sucks. That would be bad. Okay, so I'm gonna go ahead and at least start this one for you. So we'll get up at the formulas and go, hey, how much is going up by? 8 per term, right? And then I said, I'm gonna do it. What's the fixer? It's the fixer. So the fixer is the term that comes right before that. So what term comes right before 12 if you're going up by 8 each time? Well, that's got to be 4. So 8n plus 4, and then if you want to know the 20th term, you plug 20 into that. 20 times 8 is 160 plus 4, and you get 164. Good deal? So based on that, you should be able to do this one on your own. Number 21, it says, hey, there's a problem with what they tried to do to get this general thing. You tell me which one it is. And I'm going to say you can probably do this one on your own. Note 2, follow the formulas that we talked about already in class, or in this video, because Lord knows we're not in class right now, right? Okay. So here we go. So now I've got a different situation. So now we're saying we want to write a rule for a sequence. where we tell you what, like this one, what the 11th term is, not the first term, but the 11th term is, and what the constant difference is. So we know that if we go to the 11th, it's 43, and the 12th is 48. But to write the formula, we need to come all the way back here to find out what a sub 0 is, or a sub 1, if we want to write it like this. So what we're going to do is we're going to go ahead and just plug the numbers in. So it says the 11th term is 43, so I'm going to put a 43 in right there. Put it like this so you can see it straight up on yours. And then a sub 1, we don't know, right? We don't know what this term is way out here as we go back in time. But we do know that the n is 11 because there's a little subscript 11, so that's a real 11. That's a term counter, that's a number. 11 minus 1 times 5, 5 being the constant difference. So 43 equals a sub 1 plus 11 minus 1 is 10 times 5 is 50. So I subtract 50, and I get the first term equals -7. Good deal? So then what's my general formula? A sub n equals 5n. Now if the first term is -7 and it's going up by 5 each time, and I want to know what a sub 0 is, the fixer, right? Where it would actually start or originate at, I have to go down 5 more, so that's -12, because -7 minus 5 is -12. And that formula right there is what we'll solve for this one. And you could plot it out if you want on your screen and do it. But it works. Thanks for following the video. Okay, so based on that one, I believe that you should be able to do this one now. This says number 32 is, if a sub 7 is 58 and a sub 11 is 94, you should be able to figure out what a sub n is. You might have to think about, well, how many times do I have to go up to get from the 7th to the 11th term? But I bet you can figure that out. This one right here says write a rule for the sequence of the given terms. So the 4th term is 31, 5th term is 39, 6th term is 47, 7th term is 55, 8th term is 63. Remember, think about with this, what's the constant difference? And you know that a sub n equals, and looks like, goes up 8, goes up 8, goes up 8, goes up 8. So 8n. I just need to know what is the right term 0. So 3, 2, 1, 0. Let's go backwards from 31 down 8 each time. So down 8 from here, that would be 23. Down 8 from there, that would be 15. And again, I'll let you fill in the next 2 so that you know what goes here. Awesome. So one of the cool things about these sequences is that we can add them together. Okay, we can add them together. And I'm going to tell you a little story because I think this is a pretty good thing. So it goes back a long time ago, and I can't quote you on who the originator was, but there's a kid who wasn't paying attention in school and wasn't doing his arithmetic, and it's like the teacher wanted to keep him busy for a second. So the teacher said to, let's call it Johnny. Johnny, what I want you to do is I want you to add up the first 100 numbers. And the teacher thought, man, look at that. That's going to keep Johnny busy for a while, adding up all of these numbers. And Johnny was a pretty smart kid, just didn't like to always do his work. And Johnny kind of goes, I'm done. Like right after the teacher said it. And teacher's like, you cannot be done. Don't be a smart aleck. He's going to go, draw a little circle on the board, make him stick his nose in it or stick it in the corner or whatever they used to do back in the old school days. So the situation goes that Johnny actually was right. Johnny said that the sum of the first 100 numbers is 5,050, and he did that in a matter of moments. And you're like, how the heck could he add all those up? Because guess what? These things didn't exist, right? They exist for you guys, and you could do it, but it would probably take you a while. They do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, all the way up. So what Johnny did, and what's beautiful about mathematics is Johnny found a pattern. And if you take a look at this really quick, you could see this. I'm going to put in the terms right before this. So there's a big gap in here, 1 plus 2 plus 3 plus 98 plus 99 plus 100. For the 4, 5, 6, 7, 8, all the rest of the numbers in between there. And Johnny went, look, the first and the last one add up to 101. The second one and the next to last one add up to 101. The third one and the next one add up to 101. And realize that if you go one up here and one down here, their sums are always going to be 101. So then he just had to ask himself, well, how many are there? Well, if there's 100 numbers in the list, and I needed 2 of them to get to 101, then I just got to take that 100 and cut it in half, which is 50, and multiply those together. 101 times 50 is 5,050, because there's going to be 50 pairs, right? 50 pairs of numbers that add up to 101. Like, dang, Johnny, you're pretty flippin' smart. And Johnny basically, if you do it this way, took and said that any arithmetic sequence works that way, even if it's not consecutive numbers like 1 plus 2 plus 3. It might be numbers like 4 plus 13 plus, and that went up 9, right? Plus 22 plus 9 more is 31. That anytime that you go up with numbers in an arithmetic sequence, the first one and the last one will equal the same amount, and the next one and the next one will equal the same amount, right? 35 and 35. So that works for any arithmetic sequence. This formula can be summarized as this thing right here. S of n equals a1 plus an over 2 times n, where a sub 1 is the first term in your sequence. A sub n is the value of the last term in your sequence. N is the number of terms, 1, 2, 3, 4, in your sequence, and you simply divide that by 2, and that's always going to work. So I'm going to try it right here on this one right now, right? So the first term is 4, last term is 31, so that's 35. Divided by 2, so I got 35 divided by 2 times 4. So the 4 and the 2 cancel out, gives me an extra 2 there. 2 times 35 equals 70. Do these 4 numbers add up to 70? And the answer is yes, they do. Okay, does that make sense? So this problem number 47 says find the sum of this. So you got that little sigma notation stuff, right? Down on this really close here. That little sigma notation stuff says I equals 1 to 20. So that means we want to sum up the first 20 terms. You know, we did some of these by hand before, but now we're going to see if this makes more sense. So according to this formula over here, I need the first term and the last term. So the first term, we'll plug 1 in. 2 times 1 is 2. 2 minus 3 is negative 1. Plug in the last term, that's 20. 2 times 20 is 40. 40 minus 3 is 37. Over 2 times by n, 20 numbers. Good deal? Negative 1 plus 37 is 36. Divided by 2 is 18. 18 times 20 is 360. So look at that. I just added up all of those numbers in that sequence. Got 360. Now, I could write them all out. I literally, you could write them all out. You could write out the first term, second term, third term, all the way to the 20th term. But know that that's what you're going to get. Okay. And that kind of takes us to this one right here, where it says find the sum of those first 31 terms of this thing. Okay, do what we just did on the last problem. Number 53, find the sum of the first 19 terms of this thing. So I think what you probably want to do, this is up to you, but think of it this way. N equals 1 to 19, and then you just need to go, well, what's the formula that generates that sequence? And we've been doing a bunch of those, so you just go ahead and write that in. And then thinking about making that work. And again, that formula, just to be clear, only works for arithmetic sequences. And that takes us to number 55. So it's an application problem. So we got a band Going out marching band is arranged in rows. First row has 3 band members, and each row after that has 2 more band members in the first one. So 3, and then 5, and then 7, and so on like that. And that's kind of how it's projecting as they go across the field. Okay, so it says write a rule for the number of band members in the nth row, which just means a sub n. We don't know what row it is for whatever, so it should work for any row. And then how many band members are in formation with 7 rows. Now be clear on this, how many band members are in formation with 7 rows. So that's the sum of them. Doesn't say how many are in the 7th row, it's how many are in the formation if there are 7 rows. Okay, does that make sense? So that means we got to add them all up. So that is what that's what 8.2 looks like. So this was arithmetic sequences in series. This one does. So sometimes it's nice to see somebody's face. Keep working hard at this stuff. Take your time, do it. Let's see if we can get some credit for this in this class. Okay? Good deal. Poof, section 8.2.